Okay, here we're going to talk about electrochemical cells. Now, most in everyday life, most people would call these batteries, okay, uh, which isn't quite correct. A battery is actually two or more electrochemical cells connected together. But right, what do they do? Electrochemical cells. What do batteries do? They provide a supply of electric current, electrical energy. Now, how do they do that? What they do is they convert chemical energy into, well, so the chemical energy can be used to drive an electric current, make an electric current flow. Right, so this cell here is called an alkaline cell. So like a Duracell battery, they use in TV remotes and lots of different things, and you use them once and you throw them away. Now, you don't have to know the chemical reaction that occurs in these batteries, but here it is. There's the equation for it. So zinc reacts with manganese dioxide to give you zinc oxide and Mn2O3, sorry. I just show you that just to show you that it's not magical. It's just a normal chemical reaction that's occurring. This reaction, of course, must be exothermic, and the chemical energy is used to drive a current. And in this case, the zinc is actually the negative end, the negative terminal. But you can see the zinc here turns here into zinc, and zinc oxide must be the Zn2 plus ion. So you can see what's it done? It's lost 2 electrons. And those electrons will be given out by the negative end of the battery, the zinc. They'll be used to light up a bulb or whatever. And then they'll go back into the positive end of the battery where you get the MnO2. These batteries are non-reusable. Once you've used them, once they're dead is when all the zinc and all the manganese dioxide has been used up here, when that's all gone, and the battery no longer can give a current. Okay, so let's look at another kind of electrochemical cell. Right, this is the lithium-ion battery, and these are only about 20 years old, but they are used lithium-ion cell. They're used in mobile phones, in laptops, and they're even used in modern electric cars now. Okay, now why are they used is because they are rechargeable. We'll talk about that in a minute. And also they're very very high energy to mass ratio. So they provide a lot of electrical energy, but they don't weigh very much. Okay, so this is if you in an old-fashioned mobile phone, you could take the back off and you look in the mobile phone battery would be about that big. It'd be a couple of millimeters thin. There's the two contacts. One of them is going to be the negative electrode, and one will be the positive. I'll make that the positive, red, and the negative here. Okay, now what happens, again, you don't need to know the chemical reaction at all, but this is an exothermic reaction. When lithium reacts with cobalt dioxide, you form lithium ions. That's why they're called lithium-ion batteries. And sorry, that should have a negative charge on it there, CO2 minus now. Okay, that's what happens when you use the battery in your phone. And what happens is the electrons are going to come out of the negative electrode. They're coming out the lithium there, and they're going to go round through the load in the mobile phone, whatever. They're going to go back into the positive electrode. And you can see the lithium must be the negative electrode because it starts off as a lithium atom here, and it ends up being a lithium ion Li+, so it's lost an electron, and that electron is pushed around the circuit. Right, now when your battery goes flat, it's because you have run out of lithium and the other thing there. So when you recharge it, what you do is you take away, the load, and you replace that with a power source, and you make the electrons flow round the way they don't want to go. So they're going backwards now, right? Those electrons are going back, and they're converting the lithium ions back into lithium atoms. And you're recharging the phone battery there. So basically you're making the chemical reaction go backwards, and you need energy to do that. So you have to provide electrical energy from where you plug it in order to push the electrons around the other way. Okay, so that's a lithium ion battery or cell, and they're used in phones, computers, and everything, and they're very light and very easy to recharge and so on. Let's just look at one more kind of battery, and you don't have to remember any of these kinds of batteries. These are just like to illustrate the different varieties available. So this one is it's called a lead acid battery, and you find them in cars, not electric cars, but petrol, diesel cars. This is the car battery that starts the engine, that runs the lights and that kind of stuff. Now, what that consists of is this is one cell, and a car battery will have 4 of these cells in it, side by side, connected in series. Each cell then has got 2 lead electrodes. The positive one has got a thin coating of lead oxide on it, and the negative electrode is just lead, and they are in a solution of sulfuric acid. Okay. And what happens when you draw a current from it? So there's a light bulb or whatever. Electrons are going to come from the negative lead electrode into the positive lead electrode, which has got the lead oxide on it. And what happens there is the lead oxide coating gets converted into lead sulfate. Okay, now don't worry at all about this reaction. You wouldn't be asked to recall it. I think it's just to show you that there is a chemical reaction going on in there. In that direction, it must be exothermic. So the chemical energy is converted into pushing electrons around the circuit. Now, when you want to recharge the battery, again, so you put in a voltage, and you make the electrons go around the way they don't want to go. So they'll reverse. The electrons will go in reverse. They'll go. They're going to go back that way now, and you'll make this reaction go backwards, and you build up the lead oxide coating back on the surface of the lead electrode. Right. What's good about these batteries, these lead acid batteries, are they can provide very large currents, bigger currents than can a lithium ion battery. And you need a very large current for the starter motor in a car. It draws a really large current for a very short amount of time, and they're really good at that. Also, you can use it to power the lights and all that kind of stuff, the radio and all that kind of stuff in the car. It's very important this battery is rechargeable, and it gets recharged by you have a generator in the car called an alternator that runs off the petrol engine, and that recharges the battery constantly. So if you leave the car with the lights on, when the engine's switched off, the battery will go flat and it won't start the next morning. Okay, so they're good. They can provide very large currents, but what's bad about them is, well, you've got loads of sulfuric acid here sloshing around. Which it would not be suitable for something you've got to carry. It's all right in a car where it's like bolted onto the engine, underneath the bonnet, where it's not going to spill. It's okay there, but it wouldn't be any good for a mobile phone or anything, obviously. Also, it's very heavy because it's got lead in it. That doesn't matter in a car. And so it has its advantages in certain situations over a lithium ion battery. Now, what you don't have to remember about the practical details of any of these cells I've talked about. You just have to be able to interpret information that they will give you. They will say, this battery is heavy, but it provides a large current. What kind of situation would it be suitable for? Sort of really quite easy stuff without any real chemistry in it at all. just evaluating the evidence that is given to you.